Good morning all. Today I'm going to use a little pin header like this one here with some coloured LEDs and a single inline resistor pack so that I can use Arduino as an ISP. So what's an ISP? Well, it's an in-system programmer. Now these are all in-system programmers. These two here are the USB ASP ISP, if you like, in-system programmers, USB as I like to call them. In fact, you can see the name there, USB ASP version 2.0. Now these two here are USB tiny ISPs. This is an older version which isn't quite so tiny. This is genuinely tiny USB tiny ISP. And these things are used for programming Atmel AVR chips while they're in a system. So here's an Atmel AVR chip in a system. It's sitting on the Uno board, and I can use this USB tiny ISP, which has a USB connection there, to program this chip by plugging this cable onto this header. Got to make sure I get pin 1 the right way around, of course. Now normally in the world of Arduino we don't use in-system programmers because Arduino has a thing called a bootloader in the chip which wakes up, says, hey, are you sending me a new program over USB? If so, I'll load it into most of my memory, but not, of course, overwrite the bootloader. So we don't need in-system programmers for day-to-day Arduino programming. Now, one instance where you might need a programmer is if you want to reburn the bootloader into an Atmel chip, say it gets corrupted, or maybe you have a brand new Atmel chip that you've just bought, it has no bootloader in it, and you want to program one in, well then of course you do need an ISP. Now you don't actually have to buy one of these ISPs, one of these off-the-shelf ISPs, because you can actually use Arduino itself as an ISP. We can put a little sketch into the Arduino which turns an Arduino board into an in-system programmer. And that sketch is here in the IDE software. It's under Examples, and there it is, Arduino ISP. Let's open that up. So here it is, Arduino ISP version 04M3. This sketch turns the Arduino into a AVR ISP. Now, we've got to be a bit careful here because on the Arduino Genuino website, there's a relatively new product called Arduino ISP, but this is not the same as the sketch called Arduino ISP. This is another in-system programmer. There's a bit of an overview here about it. It's based on David Mellis's project Fab ISP. With this programmer you can upload sketches and burn the bootloader on any AVR-based boards. Well, you can do the same with all the other ISPs I showed and Arduino as an ISP. Now, to try and make sense of this, I've just gone back to the Arduino IDE, the Integrated Development Environment. If you look under Tools and come down to Programmer, here's a list of all the programmer types. Now let's ignore the top two for a minute. Here's my USB Tiny ISP. Here's the Arduino ISP, which is, I think, the board that I've just shown you. Here's the USB ASP or USB. There is an older parallel programmer. And the one at the bottom, Arduino as ISP, is the one that I'm concentrating on today. So despite the name in the sketch here, Arduino ISP, I'm going to refer to this as Arduino as an ISP from this point on. So the first thing I'm going to do is I'm going to load that sketch, Arduino as an ISP, into this Arduino Uno. Now this is a clone Uno. It has the female header pins and also male header pins, and I've chosen this over the genuine Uno, mainly because of those male header pins. So let's load that in now. So under Tools, my board is not a Nano, it's an Arduino Uno. My port is COM5, that looks good. Let's upload the sketch. Just check that that all compiles and upload successfully. Let's make sure it does. I've got my verbose dialog on, so it might take slightly longer. Uploading. done uploading. Good. So the sketch has uploaded successfully, but there isn't a lot to see. There are no flashing lights or anything like that. D13 LED here is just off. So that's where these components come in, because actually there is a heartbeat light going on to tell you that the software is running, but you can't see it until you connect some LEDs to pins 9, 8 and 7. And there is a note about this in the sketch. It says here, look, put an LED with a resistor on the following pins. Pin 9, heartbeat, shows that the programmer is running. Well, that would be useful. Pin 8, error, lights up if something goes wrong. Use red if that makes sense. Okay, I will. And pin 7, programming, in communication with the slave. Well, these lights would be very useful. So I'm going to build that little pin header with LEDs on these three things. Now, they say use red for error. That's fair enough. I kind of wanted to use red for heartbeat, but maybe I'll use yellow for that. And programming in communication. Well, that sounds positive, so I think we'll use green for that one. Now, if I'm going to build this pin header so that it spans from ground, because I'm going to need ground for the other side of all the LEDs, at least from ground, and then we need pins 9, 8 and 7. Well, that's a nuisance because pin 7's on this other header, and the gap between these two headers is that awkward 1.5 tenths of an inch, or 150 thou. So the pins don't line up with this second header. So what I'm going to do is I'm going to break it off here and bend this pin out a bit so it spans over that unusually large gap. So it's a bit of a fudge. I've had to bend that last pin out, but I think it's going to work now. That will go from ground on the left and span out over into the other connector block. I hope the pin's still long enough to get into pin 7. So I need LEDs on 7, 8, 9, and then the common pin of my resistor will go up to ground. Just going to do a quick continuity check to make sure that that is sitting in pin 7. Yep, that seems fine. Now I'm using a 270 ohm single inline resistor pack here. No particular reason for the value, it's the highest value resistor pack I could find, but anything between about 220 ohms and, oh, I don't know, 1k probably would do. This is going to mean I'll have quite bright LEDs. Now I need to attach it to the header a bit like stuck on top of the header, a bit like that I suppose. Pin 1, the common pin with the dot there, will line up with my last pin on the header so that I've got my ground connection, and then the LEDs will span resistor connections and connections on the header, including the very last one, which is bent out. Now I could use glue for this. I've gone with tiny amounts of blue tack there, so I just want to stick that on there so that all these pins line up, and then I can solder my LEDs onto pairs of pins down there. So let's first solder the common pin of the sill resistor onto the last pin of the header here. So that's ground. So that kind of anchors the resistor to the header. Now I'm just going to tin the 6 connection points for the LEDs. Can't get to that very well. Let's bring that round a bit. So 3 points on the sill and the 3 end pins. Whoops, I'll fix that in a minute. The 3 end pins on the header. And now I'm going to cut down the legs of a yellow, a green and a red LED, quite short, and tin those legs so that I can stick them onto across the sill and the header. Now the flat side of an LED, the leg on the side with the flat, is the sort of earthy end. That's the low voltage end, so that's going to go to my sill, so it goes through the resistor and back to ground. So the LED wants to go this way round. Now this is the hard bit, soldering it on to both pins. I've angled it slightly out because I don't think these LEDs will sit 1/10 of an inch apart. In fact, they won't, will they? Because 1/10 of an inch is 2.54 millimeters, and these are 3 millimeters. So they are going to be slightly splayed out. So yellow is pin 9, which is heartbeat. Red is pin 8, which is error. So I'll solder that one on there. It is proving to be a bit of a tight squeeze, actually. Can't see what I'm doing. I'll have to do that without the camera in the way. Well, it's not beautiful, but it's probably good enough. Now I've cut the other legs off the sill just so that they don't interfere with anything, don't get in the way. So there are the 3 LEDs. They span from the header across to the single inline resistor, and then the ground pin is connected through to this end pin. Now if I plug this into the Arduino, making sure that the green LED spans across to IO pin 7, D7, red is on 8, yellow is on 9, which is the heartbeat, and that's it. So let's plug it in, and of course this is running the Arduino Isp program. The bootloader's just getting ready to run the internal program, and there it is. And you can see that the yellow LED is doing this fade up and down thing. Now that's the heartbeat. That shows you that Arduino as an ISP program is running on this Arduino. Now this is where it all gets a bit complicated, because I've just done a search on the arduino.cc site for ISP, and I've got various results. These first two I'm pretty sure are related to the Arduino ISP hardware product, that little board I showed you earlier. But this third one says this tutorial explains how to use an Arduino board as an Avr ISP. This is the one we want. So let me just click on that. Yes, using an Arduino as an Avr ISP in System Programmer. So scrolling down on here under instructions, there is one thing it says here for Arduino 1.0, that probably won't affect me. You need to make one small change to the Arduino ISP code, find the heartbeat function and change delay 40 to delay 20. Well, in my Arduino 1.6.5 IDE, it already has delay 20, so that's fine. They've obviously updated that. And then further down in this tutorial, you've got a little diagram of the 6-pin ISP header. And then you've got instructions on how to wire the Arduino that is now Arduino as an ISP to another Arduino, the one that you actually want to program. Now, I think this is all a bit confusing, so I'm going to use my Arduino as an ISP to program a bare chip on a bit of breadboard. And so scrolling down a little bit further from targeting the Uno, that's an Uno there, to targeting an Arduino NG. I mean, these are really old models. But here we've got targeting an Avr on a breadboard, and we are going to need the clock components, the crystal and the 2 capacitors. So I want to wire it up pretty much like that. So here's my setup, wired pretty much according to the diagram on the tutorial. I've got VCC and ground here powering my target system, which has an 80 mega 328p, 16 megahertz clock crystal, a couple of 20 picofarad capacitors. The green wire is reset, comes from pin 10 on Arduino as an ISP to pin 1 of my target chip, that's the reset pin. And then these 3 wires, I've used black, white and grey, come from pins 11, 12 and 13 on the Arduino as an ISP. They are MISO, MOSI and clock, not necessarily in that order, and they go to these 3 pins on my target system. Now my target microcontroller appears to have the blink program already in it, because that LED on digital pin D13 is switching on and off at 1 second intervals. But hopefully I can use my Arduino as an ISP to upload a new sketch to this system, change the speed of the LED. So I've now opened a blink sketch. Here it is, blink. I've changed the delay times to 250 milliseconds on and off so that the LED blinks nice and fast. Now I'm not going to upload this sketch using the regular sketch upload. I'm going to use upload using programmer, but I've got to set the right programmer first. Now currently the programmer is set to a USB Tiny ISP. I need it to be Arduino as ISP. So here we are, upload using programmer, but before I click that I'm going to point my camera at the little set of LEDs that I just built, because I want to see what they do when I actually upload my sketch using the Arduino as an ISP programmer. So I'm just going to click upload using programmer. There we go. That's compiling at the moment. So nothing much is going to happen while it's compiling. Now it should be uploading now. Yeah, a flash of lights. And that's it. We now have the faster blink sketch in the target system. The LEDs flashing on and off more quickly. The heartbeat's back pumping again on my programmer. So that appears to have worked. Brilliant! Now you can also use an ISP to burn the bootloader. So I'm going to burn an Arduino Uno bootloader into my target system, the chip on the bit of breadboard. Common port doesn't actually matter because we're going over the ISP. So Arduino Uno, burn bootloader. Let's point the camera back at the breadboard. Now I think burning a bootloader is fairly quick, so let's click that button. Green light comes on. And that, I believe, it says done burning bootloader. Now this LED is no longer flashing, and that's because when you burn a bootloader you effectively wipe everything out of the chip, but that chip should now have a bootloader burnt into it. Now the best way to check whether the bootloader successfully loaded into this chip is to now use this as a conventional Arduino Uno setup. So I've put a USB to serial converter, CH340 here. I've connected up TX and RX and reset. Reset has to go through a 100N capacitor, so I've just bodged that into place. VCC and ground, and let's just do a regular upload and see if it works. And yeah, that seems to have worked. The bootloader has taken the program has gone in, it's the fast blink that I had earlier. This chip is working as an Uno. So that's it. That's how to use an Arduino as an ISP, an in-system programmer. And I do think that it helps to build this little 3 LED array, because then you get to see the heartbeat, any errors that might occur, and green for successful programming. Cheerio.